Alright, AP Calc. In this video, we're going to start going over implicit differentiation. And I'm going to work out the evens on this page that you have available to you. So first off, we want to talk about what implicitly defined functions are. Well, explicitly defined functions are functions where we have y isolated and we have a function in terms of x. So we can look up here above. So for example, we have y equals 3x squared plus 4x plus 5. That's explicitly defined because we got y by itself and it tells us exactly what to do with x to get y. Or example 2 is actually the same function. We can easily isolate that for y and get the y by itself. And so we could kind of say that that's explicitly defined as well if we just move it around and get the y by itself. But sometimes we have a relation between x and y where we can't just isolate the y and get the y by itself. And these can come in very common ways. The first one here, x squared plus y squared equals 4, that's actually going to be a circle that's centered at 0, 0 with a radius of 2. And here's another one, x squared plus xy minus xy squared minus x squared y equals 4. So that's a little bit more complicated. And you should be able to see you can't just get the y by itself there. And these are relations. They're not necessarily functions. They won't necessarily pass the vertical line test for a function. So how do we differentiate these? Well, implicit differentiation allows us to take the derivative of these types of functions, and we do so using the chain rule. So when we differentiate something that just has an x with it, we differentiate as usual. But if it has a y in it, then we also need to use the chain rule to take the derivative of the y and get a dy dx. So for example, let's take a look here at number 2. And what we're going to do is we're going to differentiate both sides here. So on the left here, we have the derivative of x cubed. And if we differentiate with respect to x, that's going to give us 3x squared. We take the power to the outside, drop it down, then we have our equal sign, and then we come to this y term, and we're going to differentiate that too. So the derivative of the outside is going to be 6y. But remember, y here is really a function of x, so we also need to multiply by dy dx. And then the derivative of the 4, well, 4 is a constant, so the derivative there is 0. Now, once we got into this form, we're able to actually solve for dy dx. So we're not quite done yet. We want to get the dy dx by itself. Since it's multiplied by 6y, so here we have 3x squared equals 6y, and we want to get the dy dx by itself. So we're just going to divide both sides by 6y. So we got 3x squared over 6y is equal to dy dx. And of course, maybe we want to simplify that. So dy dx is equal to x squared over 2y. And that would be our answer. So when we get the derivative, it's usually going to be a relationship that's between x and y. All right, here we are in our next examples. So for number 4, same thing. We're going to take the derivative of 5x cubed. That's going to be 15x squared. We have the equal sign. Then we take the derivative of 2y squared. Using the power rule, that's going to be negative 4y. Drop it down a power. Since it has a y in it, we have to remember, okay, we got to do the chain rule here. So we're going to have dy dx. So anytime we differentiate y, and we're differentiating with respect to x, we're going to have to use a chain rule and introduce that dy dx. And then the derivative of a constant is just 0. So again, we want to get the dy dx by itself. And here we would have to divide both sides by negative 4y. That's going to give us dy over dx equals 15x squared over negative 4y. For number 6, Here I've got two terms that have a y in it. So now it's a little bit different because, okay, I got to differentiate the first one with respect to x. Use a chain rule. There is going to be 6y dy dx. But then the next term also has a y in it, and we have to use the power rule. So that's going to be 6y squared, and again a dy dx because we differentiated with respect to x. And then over here, power rule, that's going to be 15x squared. But now we've got the dy dx in two terms. Well, to help with that, we have to factor out the dy dx first. So you see a dy dx there and a dyx there in the second term. And if we factor that out, we're going to have 6y plus 6y squared equals 15x squared. And then once you factor it out, now we can divide by all of that on both sides. So dividing both sides by 6y plus 6y squared is going to give us the dy dx. And of course, we might want to simplify that. So you can see that 3 is going to go into everything. So that's going to give us 5x squared over 2y plus 2y squared. And that would be our final answer. For number 8, again, we've got two terms here that have a y in it. And again, we're going to use the power rule. So the derivative of 4y cubed is going to be 12y squared dy dx plus the derivative of this is going to be a 3. Don't forget the dy dx. So anytime you have to take the derivative of a y, because we're taking the derivative with respect to x, we're going to have this dy dx there. And then on this side, the derivative of 3x squared is just going to be 6x. And again, the dy dx appears in two terms, so you factor it out. We're going to have dy, let me fix that a little bit. We're going to have dy dx taken out here, and inside we have 12y squared plus 3 equals 6x. And divide both sides by this 12y squared plus 3. So if we simplify that, we're going to have dy dx equals, everything here can be divided by 3, so we get 2x over 4y squared plus 1. All right, continuing on with 10 and 12. In these examples, we have terms that have both x and y in them, and we're going to have to use the product rule in order to differentiate these. So let's take a look with number 10 here. The derivative of the first term, derivative of 2y with respect to x, is going to be 2. And again, we need a dy dx there. And then we go to the second term here, and we got to think of this as a power. So think of this as, 4x cubed times y. So we have our plus sign here. First would be 4x cubed times the derivative of the second would be dy dx plus the second, well, the second here is y, times the derivative of the first. And the first here is, going to be 12x squared. Okay, so when we do the derivative of this second term here, we're going to have to use the product rule. First times derivative second plus second times derivative first. And that equals, on this side, we're going to get a 2. Okay, so simplified, again, we want to keep our y terms here together. And we're going to subtract this first to move it to the other side. So keep all the y terms here together. So that's going to give us 2 dy dx plus 4 x cubed dy dx equals 2. And then we're going to subtract this. I'm going to just write it as 12x squared y. And now we're going to do the same as what we did in the previous example. Since I have dy dx in two terms, factor that out. Dy dx, take it out of there, leaves us with 2. Take it out of here, that leaves us with 4x cubed. And then we can divide. So we're going to divide both sides by 2 plus 4x cubed. And, usually you could just leave it like that. If you want it simplified, we could take out a 2 from every term here. That would leave us with 1 minus 6x squared y, 1 plus 2x cubed. And that would be our final answer. So for number 12, again, we're going to start here, take the derivative of 5x cubed, that's 15x squared. The second term here has both an x and a y in it, so we need to use the product rule. Think of it as negative 5x times y. So we want to take the first, which will be negative 5x, times the derivative of the second. Well, the derivative of y is just dy dx, plus the second, which would be a y, times the derivative of the first. So that's going to get multiplied by a negative 5. So we use the product rule on that, and then we go over here, equals power rule 9y squared, and again, since that has a y in it, we're going to have a dy dx. Well, in this case, we've got the dy dx's on opposite sides here, so we want to simplify this and get all the dy dx's together so that we can isolate it. So a little bit of math here. We got 15x squared minus 5y from this guy equals 9y squared dy dx. And since this is subtraction here, we're going to add it to the other side, plus 5x dy dx. And now we can take out the dy dx over here on the right side. That's going to leave us with 9y squared plus 5x. And after we factor out the dy dx, we can divide out both sides by 9y squared plus 5x. So what are we going to get? We're going to get dy dx equals, what do we have here? Can we simplify that? Doesn't appear that there's anything that goes into everything, so it's just 15x squared minus 5y over 9y squared plus 5x. Okay, number 14. With 14 and 16 now we're dealing with some trig functions here. And we can see that inside the trig function we have both x's and y's. So we got to be a little bit careful. So for 14, we want to take the derivative of cosine. The derivative of cosine is negative sine. The inside is going to stay the same. We're going to have to use the chain rule. So it's the derivative of the outside times the derivative of the inside. Now the derivative of x plus y with respect to x is going to be 1 plus, derivative of x is just 1. Derivative of y is going to be dy dx. And then we're going to go to the right side here. The derivative of 6y is just 6 dy dx. And the derivative of negative 2x is negative 2. Now the problem here is that the negative, this is going to get multiplied by this. And we got a dy dx in here, so let's multiply this out. We have negative sine x plus y multiplied by 1 plus another negative sine x plus y, and that is multiplied by dy dx. So basically I distributed this term to both of these. On this side I have 6 dy dx, and I have minus 2 here. And I want to get the dy dx's together and get the other stuff that doesn't have a dy dx to the other side. So let me add this term to the other side. So I'm going to still have negative sine x plus y dy dx. And over here, 6 dy dx minus 2 plus, so I'm adding this to both sides, plus sine of x plus y. And then at the same time here, I'm going to subtract this 6 dy dx. And I'm breaking this up into steps here, so you may see, oh, you could do this a little bit faster, doing a couple things at the same time. And then we want to factor out the dy dx from both of these terms. And that's going to give us a negative sine x plus y minus 6 equals sine of x plus y minus 2. The last step then would be to divide by this after I factored out the dy dx. So I'm going to divide by negative sine of x plus y minus 6. And divide this by negative sine of x plus y minus 6. So this would be my final answer. So this one's a little bit more complicated again because, well, we have this sign here and we have to multiply by the derivative of the inside. We have to then distribute to get the dy dx out of it. Then we got to move the dy dx's together and move all the other stuff that doesn't have a dy dx together on the other side. Factor out the dy dx so that we can divide. So now for 16, you may have guessed that this is going to be kind of similar to 14 because now we have a cotangent and we have x minus y inside of it. And you'd be right. So we want to start off with the same thing. So we take the derivative of the outside. What's the derivative of the cotangent? That is negative cosecant squared. The derivative of the inside here is going to be the same. So it's going to be x minus y. Then we have to multiply by the derivative of the inside. So that's going to be 1 minus dy dx. And then we go to the other side here. The derivative of 3y is going to be 3 dy dx. And the derivative of negative 5x is just going to be a negative 5. So again, every time that we're taking the derivative of a y, we're going to have that dy dx. Now we didn't have to worry about it here because we were using the chain rule. And we just took the derivative of the outside. The inside stays the same. But then we had to take the derivative of the inside. The derivative of x minus y is going to be 1 minus dy dx. And here we have the dy dx. It's in this parentheses, so we have to distribute first to get it out of there. So that's going to give us a negative cosecant squared x minus y. Multiply that by 1, nothing happens really. But then we're going to multiply it by a negative dy dx. Since we got a negative times a negative, that's going to be a positive. Cosecant squared x minus y, and then we'll write the dy dx here at the end. And then on this side we have 3 dy dx minus 5. And let's see if we can do two things here at once. So I'm going to get the dy dx's together. So basically I want to move this over to the left side and I want to move this over to the right side. So after adding and subtracting both of those, we're going to have cosecant squared x minus y dy dx minus 3 dy dx, because I subtracted 3 dy dx there, equals, and then remember this is going to move to the right side, so that's going to be positive, cosecant squared x minus y minus 5, because minus 5 is already there. The dy dx we can factor out from both of these terms here. Cosecant squared x minus y minus 3. This part's going to stay the same. And then we want to divide to get the dy dx by itself. And divide this. So we end up with cosecant squared x minus y minus 5 on top, and then cosecant squared x minus y minus 3 on the bottom, and that's going to be dy dx. So I should finally write here dy dx is equal to that for my final line. All right, for this last section here, we want to find the tangent line to a given point, and we have to use implicit differentiation. So to get the equation of a tangent line, remember we need to have two things. We need to have a point and a slope. Well, we already got the point here because it gives us the point, so we need to find the slope here. So to find the slope, we need to differentiate. So we are going to take the derivative here. The derivative of 4x cubed is going to be 12x squared. And then the derivative of negative 5y is going to be negative 5 dy dx. And then over here we have 2y dy dx. Now we want to get the dy dx's together. So let me just rearrange this. So I would have 2y dy dx, just switching sides. And I'm going to add 5 dy dx to that, equals 12x squared. So I'm just putting that together, the negative 5y dy, adding it to both sides, and switching the left and the right side here. So that should make sense. And then we're going to take out a dy dx, factor it out. That gives us 2y plus 5 equals 12x squared. So now we solve for dy dx, and we're going to have 12x squared over 2y plus 5. And remember that the derivative here gives us the slope. So all we have to do now is to put in our values for x and y. So 12 for x, we're going to put in negative 1. And then for y, we're going to put in negative 4. And simplify that, make sure we square that. On top, we're going to get 12, it looks like. On bottom, we get negative 8 plus 5, which is negative 3. The slope of negative 4. Now we can write our equation. Y equals, use the point slope formula, y minus y1. What is y1? Y is negative 4. So y minus negative 4 is y plus 4 equals negative 4 times x minus a negative 1. So you could just leave it like that, or you could put it into slope-intercept form. And in slope-intercept form, it would look like y equals negative 4x minus 8. Okay, number 20. The derivative of 4x cubed is going to be 12x squared equals, oh no, now we have another product rule here. So it is first times derivative of the second. Well, the derivative of y cubed is going to be 3y squared dy dx, since we took the derivative of a y. First times derivative of second plus second, that's a y cubed, times the derivative of the first, 3x squared. So make sure we got it. First derivative second plus second derivative first, plus the derivative of y squared, which is going to be 2y dy dx. All right, simplify this. So we have 12x squared, and we have to subtract this from the others, from both sides. This doesn't have a dy dx, so let's move it over to the left. That's 3. I just put it in order, 3x squared, y cubed. And then we have all of our dy dx's here on the right side. Let's just put these in order and make sure they look nice. So this is 3x cubed y squared dy dx. And then this is 2y dy dx. So we'd have to factor out the dy dx here. And we get dy dx. Take that out. So that leaves us a 3x cubed y squared plus 2y. Over here, 12x squared minus 3x squared y cubed. And then divide both sides by that. 3x cubed y squared plus 2y. And here, x is going to be -1 and y is going to be 2. So we want to evaluate this derivative, putting in those values for x and y. So for x, we are going to put in -1. And for y, we're going to put in 2. And then we need to simplify that. Okay, after we simplify that, we should get 3/2. So that means that the slope is 3/2. And then finally, we put it together. Y minus the y coordinate is 2 equals 3/2 times x minus a -1. So you can leave it like that in point slope formula, or you could write it as y equals 3/2 x plus 7/2. Okay, last one, 22. So again, we want to take the derivative. Here we're finding the tangent line again to the point. So take the derivative. That's going to give us 8x minus 2 dy dx equals, over here we're going to have a product rule. Let's think of it as 2x squared times y cubed. So product rule is first. That's the 2x squared times the derivative of the second, which would be 3y squared dy dx, plus the second, which is our y cubed, times the derivative of the first, which is going to be 4x. And now we want to simplify this and get all the dy dx's together. So let's write this as 8x minus 2 dy dx, and make this look nice. 6x squared y squared dy dx, plus this would be 12, this would be 4xy cubed. And so now we want to move all the dy dx's together and all the other stuff together. So let's move this over to the left side and move this over to the right side. And that's going to give us 8x minus 4xy cubed equals 6x squared y squared dy dx. And then add 2 dy dx to both sides. Factor out the dy dx. Factor out the dy dx. We're going to have dy dx and 6x squared y squared plus 2. Over here, 8x minus 4xy cubed. Divide both sides by the 6x squared y squared plus 2. And that's going to be our dy dx. So plug in. Here, x is 1 and y is 1. So 8 times 1 minus 4 times 1 times 1 cubed over 6 times 1 times 1 squared. Of course, we got to cube that, square that. Doesn't matter because it's 1. And what does that give us? On top, it looks like it gives us 4, and on the bottom, it gives us 8. That gives us a slope of 1/2. And if we go back up here, we write the equation. We have y minus 1 equals 1/2 x minus 1. So there it is in point slope formula. And we have y equals 1/2 x plus 1/2 in point, or in slope intercept formula. And that is it. Hope you found this helpful. Let me know if you have any questions. We'll see you. Bye.